Limits at infinity. When we plug in infinity, you see we get infinity over infinity. Actually, we get 3 minus infinity. That's still infinity. And infinity minus 3, minus 1. Anyways, you get infinity over infinity, which is indeterminate. So in order to find the limit as it approaches infinity, we divide each piece by the highest degree in the denominator. So what is it? X cubed. So the limit as x approaches infinity, you're going to have 3 over x cubed minus 2x over x cubed over 3x cubed over x cubed over minus 1 over x cubed. Now, why can we do that? Basically, we're multiplying top and bottom by the same thing. You're multiplying by a fraction. Got it? You can always multiply top and bottom by the same thing, and that's what we just did. Okay, we do all that. We now have the limit as x approaches infinity of this. What's this one become? 2 over x squared. And this one, doesn't that become 3? Because these cancel. Now, how does that help? Well, if I plug in infinity now, when I plug in infinity, by the way, when I plug a value in, can I drop the limit sign? Yes. I'm plugging the number infinity in. 3 over infinity is 0. 2 over infinity, infinity cubed. 2 over infinity squared is still 0. That's 3. And what's 1 over infinity cubed? 0. So what does it look like our answer is? It's 0 over 3, which is 0. So as we go to infinity, your graph is going towards 0. You actually have a horizontal tangent line at x equals 0. Not x, sorry. Horizontal tangent lines are y equal. Y equals 0 is actually a horizontal tangent line on the infinity side. It could be different on the negative infinity side. Okay, B. For this one, do the same exact thing, except what do we divide by? Divide by x. There are shortcuts to this. You don't always have to write all the steps out. By the way, most people can actually kind of visualize this without writing all the steps. What you end up with is the limit as x approaches infinity of 3 over x minus 2 over 3 minus 1 over x. And what does it look like we get when we plug in infinity? Then we get 0 minus 2 over 3 minus 0. So don't we have a horizontal tangent line at y equals negative 2/3? There'd be a horizontal tangent line at y equals negative 2/3. The answer is negative 2/3, but if we thought in horizontal tangent lines, now I think the question is just asking what's the limit, so the answer is negative 2/3. But I'm trying to switch your thoughts into horizontal tangent lines. So again, that's your answer. That's your answer. And the last one here, what are we going to divide everything by? X, correct? Let's skip all the work. When we divide by x, that's 3 over x. When we divide by x, what do we get? 2x. And then here you get 3. And then 1 over x. Is that okay to skip the step? Just kind of write it real quick. Plug it in infinity. When you plug in infinity, what do you get here? Well, that's 0 minus, what's 2 times infinity? That's infinity. And that's 3 minus what? 0. Okay, is that, oh, by the way, the last one was infinity over infinity to begin with. Were you okay with that? Was this infinity over infinity to begin with? Forgot to check that. Sorry, you're supposed to check that first. Just make sure it's infinity over infinity. Now, Is this still infinity over infinity? No. What's my answer? It's just infinity. Infinity over 3, which the infinity beats out the 3. Ooh, very good. Thank you for reminding me. It's negative infinity. So what does that mean? What that means is as x approaches infinity of this graph, it's going to be going down. Do you understand that? Your graph's going to be going down forever. Just basically describing. So this one's negative infinity. So far. Okay. Number 30. What you have to realize is this ends up being infinity over the square root of infinity, which is still infinity. So this is infinity over infinity. So we can divide by the highest power in the denominator. Now, what you got to realize, the denominator is not x squared. The denominator is square root x squared. And the key here is there's a negative there. You have to remember that x is equal to plus or minus the square root of x squared. Okay? Positive or negative x is equal to positive or negative the square root of x squared. So, which value are we dealing with, the negative or the positive? We're dealing with the negative x values, correct? So don't we deal with the negative square root x squared value? Alright. Now, so what I got here is the limit as x approaches negative infinity over, sorry, and then this will be divided by, so it's x, right? It's not negative x. We don't change the x to negative because that's already negative, correct? It's the square root one we got to change the negative because square root x squared will eliminate the negative that was there. So the top is just going to be negative 3x over x. Again, we don't make that a negative x because it's already negative with the negative infinity. It's the bottom one we have to worry about. And then the bottom one, when you divide by it, you end up with x squared over x squared plus x over x squared. Basically, when you divide by square root x squared, the square root lets you inside. The only way inside of a square root is bring another square root. Then once they're in, then you divide each piece by the x squared. Probably skipped a step, but probably maybe shouldn't have. Okay, we now have the limit as x approaches negative infinity. Looks like negative 3 plus 1 over x over the square root of what? 1 plus 1 over x. Can we plug in negative infinity? Yes. That becomes negative 3 plus 0 or minus 0, doesn't really matter because negative infinity would be a negative. Anyways, who cares? Okay. And then this will be the square root of 1 plus 0, correct? So does this look like a number or infinity? I see a number here because square root 1 is 1, right? Doesn't it look like we're going to have negative 3 over 1? Is the answer negative 3? So as we go to positive, as we go to negative infinity, the horizontal tangent line is negative 3. By the way, what would your horizontal tangent line be if you're going to positive infinity? The only difference, if that was a positive infinity, is you'd go down here. Shoot. I screwed up. Wasn't I supposed to put this negative in here the whole time? There was supposed to be a negative on the bottom the whole time. Got it? Because we need the negative because it was going to the negative infinity. So there's a negative here, which means there's a negative there, which means what? That should be a positive. Negative here. Okay, that is a positive 3. So the horizontal tangent line is positive 3. Now, if we are going to positive infinity, wouldn't these be positives like we just had a second ago? So the horizontal tangent line going to the positive infinity would be negative 3, the opposite of that. Sorry, you got to watch out for that little negative. It's going to mess you up on a test.